Hello everyone, Professor Vaibhav Shah here. Hope you have checked my previous lectures. If not, I insist you to go through that lectures first, which are containing basics of scales, types of scales, representative fraction or RF, way to solve examples with some of the useful solve examples. In today's lecture 4, we'll be solving some more examples based on concepts and tricks learned from previous sessions. If you like my content and teaching style, then share it with your friends and do not forget to like and subscribe to show your love and support. Let us start. So we'll be using following formulas for calculation in this topic. So first, representative factor or RF is equal to dimension of drawing upon dimension of an object. Now let us suppose if your dimension is given in the length form, so length of your drawing upon actual length. If your dimension is given in the form of area, then RF would be RF is equal to under root of area of drawing upon actual area. If your dimension is given in the form of volume, then it would be cube root of volume as per the drawing upon actual volume of an object. So this is your first equation. Now we have to use this second equation also. Length of scale is equal to RF into maximum length to be measured. So RF we can directly take from our previous equation. Maximum length to be measured must be given in your example statement, and length of scale, which is your answer. So this would be your length of scale, which we must be drawing in our actual drawing sheet. So you have to remember these two equations, equation A, equation B, which will be very useful for you in each of the examples. Now, one more thing, unit conversion tables. You have to remember this unit conversion table, and I believe that most of the examples in your examination will come from this table. So try to memorize this table. So I would suggest that we write down this table somewhere and try to memorize it. Now, it seems too difficult to memorize this table, right? So now I will give you a trick. So we'll be using this unit staircase, and here we can convert from kilometers to millimeters. So let us start. If we go up in this staircase from this shoe, if we go up, then we have to simply divide it by 10, and if we go down from this shoe in this direction, we have to multiply it by 10. So let us take one example. So let us suppose we have to convert 1 kilometers into meter. So for that, we are at the top. You can see this cat. So cat is sitting on this kilo stair. That means it is showing 1 kilometer. Now we have to convert into meters. So this shoe is representing you a base unit, which is meter. So if you have to convert into kilometer to meter, so cat has to come down by 3 steps, 1, 2 and 3, and on third step it is reaching your base unit meter. So now here we are descending by 3 steps. That means we will multiply 10 3 times. So 1 kilometer into 3 into 3 into 3, because we are descending by 3 steps, and the final answer would be 1000 meters. So 1 kilometer is equal to nothing but your 1000 meter. You can try and taste this unit staircase for different unit conversion, and you can memorize your units very easily. So now let us start with problem number 1. A room of 1728 meter cube volume is shown by a cube of 216 centimeter cube volume. Find the RF and construct the plane scale to measure up to 42 meters. Mark a distance of 22 meter on this scale. So this is a unique example. In this example, your dimension is given in the form of volume. You can see 1728 meter cube, and we have to solve this example. So let us first understand room of 1728 meter cube volume. That means your object is of this volume. So this is the dimension of your object, and you will be representing this dimension by 216 centimeter cube volume in your drawing sheet. So it is the scale is given. So you will first find out RF from the scale. After that, you have to construct the plane scale to measure 42 meters. So your maximum distance is your 42 meter, and on this scale you have to mark the distance of 22 meters. Very simple. So let us start. first finding out with RF. So now here your data is given in the form of volume. So we'll be using our equation of RF from our volume equation. So which is RF is equal to cube root of dimension of object in drawing or volume of object in drawing divided by volume of actual object. So now volume of object in drawing, which is 216 centimeter cube. So we have specified 216 centimeter cube, and here the actual volume of your room is 1728 meter cube. So we have specified 1728. Now we have converted this meter cube into centimeter cube. So we have simply just put in the place of meter, 1 meter is equal to 100 centimeter. So we have put this 100 in the place of meter, and we have specified by 100 cube. And we have taken out centimeter cube outside. So this is nothing but your room dimension 1728 meter cube converted into your centimeter cube. So once again 1728 meter cube. So we have replaced this meter cube by 1 meter is equal to 100 centimeter. So we have replaced it by 100 centimeter. So that means 100 centimeter cube. So we have specified this 100 cube and we have taken out this centimeter cube. So this is your unit conversion. After solving this this equation, we can have 1 by 200 as our RF. Now next step, our maximum length which we have to measure is 42 meter. So maximum length is equal to 42 meters. Now 42 meters can be either written as 6 into 7 or 7 into 6, which specifies you 42. So we can, in other words, we can say that actual length of scale is divided into 6 parts of 7 meters each or 7 parts of 6 meters each. So once again, we have our maximum length 42 meters. So it can be represented by either 6 multiplied by 7 or 7 multiplied by 6. In other words, your actual length of scale can be either divided into 6 parts of your 7 meters each or 7 parts of your 6 meter each. We'll see it later on. Now, first let us define actual length of scale. So actual length of scale is equal to RF into maximum length to be measured. So RF is equal to 1 by 200. So we have put 1 by 200. Maximum length is 42 meters. Now we have converted this meter into centimeters. So we have multiplied by 100 centimeter. So after solving this, we are having 21 centimeter. So first of all, we will be drawing one line of 21 centimeters. So we have drawn one straight line of 21 centimeter. And then we have given one height of 10 mm and we have enclosed this rectangle. After drawing this rectangle, we will be dividing this scale into 7 parts of 6 meters each in this scale. So 7 parts of 6 meters each. So we have taken 7 parts of this 21 centimeters. So 1, 2, 3, 4, 5, 6 and 7. So we have taken 7 parts of this. So from where we have taken these 7 parts? From this actual length of scale, we can either take 6 parts of 7 meters or 7 parts of 6 meters. So we have selected this 7 parts of 6 meters each. So we have first drawn 121 centimeter long line. After that, we have divided 6 meters interval part. So first part, second, third, fourth, fifth, sixth and 7. After that, we'll be giving the notations. So at the end of your first unit, we'll be specifying 0, 0 and we'll be taking the each unit in the interval of 6. So this is 6, 12, 18, 24, 30 and 36. Now we will further subdivide into first part. So this is representing your 6 meters. So this is also representing you 6 meters. So we'll first, we'll once again divide this first unit into subdivisions. So we can divide into 1 meters parts. So 1 meter, 2 meter, 3 meter, 4 meter, 5 meter and 6 meter. So we have divided these 6 meters into 6 parts of 1 meter each. Now after that we will be specifying the unit. So this is your subunit meters. We have specified just below your subunit or secondary scale. This is your meters. We have just specified it below your primary scale. This is your RF 1 by 200. We have specified on the right hand side of your primary scale. Now after that we will be just finding out the answer, which is we have to show the distance of 22 meter on this scale. So the length to be shown 22 meter can be divided into 2 parts, 18 meters on the primary scale and 4 meter on the subscale. So now let us find out 18 meters so on the primary scale. So 0 to right is your primary scale. So let us count 0, 6, 12 and 18. So we have drawn one vertical line. We have measured 18 meters on your primary scale. After that we have to measure 4 meters on the subscale. So this is your subscale on the left hand side of 0. So 0, 1, 2, 3 and 4. From 4, draw one vertical line. This is your 22 meters. So it is a little bit difficult example, or I would say a tricky example. So you have to just remember this RF equation, and after that you have to remember that maximum length can be either divided into two categories. So we have taken 7 parts of 6 meters. So we have divided. So let us suppose if you can't divide this particular line into 7 parts, so you will use your triangle method. If you don't know the triangle method, you can refer the prerequisite to your engineering graphics lecture delivered by me. So you can check that video. And let us suppose you can divide these subdivisions into further 6 divisions. So you can always use this triangle method here. So we'll be dividing this by your triangle method. And after that, your example is very simple. You can pause the video and go through this example once again and try to solve it by yourself and try to observe the changes. Now, let us move to one more example. Construct a plane scale of RF 1:5 to show decimeters and centimeters, and it can read up to meter. Show the length of 7.4 decimeter in it. So here we have RF is given 1:5. We have to show decimeters and centimeter on the scale. Our scale should be long enough to measure 1 meter, so which is your maximum distance, 1 meter we have to measure, and you have to show on this length of 7.4 decimeter on it afterwards. So first we have RF. So now we'll be converting this RF into actual length of the measured. So now maximum length we have to measure is 1 meter. So we can say that 1 meter is equal to 10 decimeters, obviously, because 1 meter is equal to 10 decimeters. So we can convert this 1 meter into 10 decimeters because we need the scale to show only decimeters and centimeters. So we'll compulsory have to convert this meter into decimeter because we want the scale to show only decimeters and centimeter. It is just said you have to measure up to 1 meter. It is not saying that you have to show 1 meter on the scale, but you have to show just decimeters and centimeters. For that reason, we have converted this maximum length into decimeters. Here 1 meter is equal to 10 decimeters. So from table you can always recall it. Now actual length of scale is equal to RF into maximum length to be measured. So RF is equal to 1/5, and maximum length we will take as 1 meter once again. Now 1 meter we will convert with meter into centimeters. So it will be 100 centimeters. So we can have 1/5 into 1 into 100 centimeters. So we'll be having 20 centimeters as our answer. Now, so 20 centimeter is our answer. So let us draw one line of 20 centimeter length. So we have drawn one line of 20 centimeter, and after that, let us give a height of 10 mm and let us complete this box, rectangular box. After completing this rectangular box, we have to divide this line into suitable number of equal divisions. Now, how many divisions we will divide? So we'll always use the maximum length as the decisive factor for division of this line. So maximum length is now 10 decimeters. So 10 decimeters means our significant digit is 10. So that's why we'll be dividing this line into compulsorily 10 parts. So let us divide this line into 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So these are total 10 parts. But in this case, we will just omit this first division. So we'll start numbering from this last part of this first division here. 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Always remember that your maximum division is 10 decimeters, but it will always show 1 unit less than your maximum division because we have omitted 1 unit here. So now, so this is, we have constructed our primary scale on the right hand side. Now let us subdivide this portion on the left hand side. So let us suppose this is your 1 decimeter. So now 1 decimeter. So this is also representing your 1 decimeter, but it is further divided into 10 parts. So now 1 decimeter is divided into 10 parts. That means we must understand or recall the table. So 1 decimeter is equal to, 10 centimeters. How can we say that? So we have to recall this table which says that 100 centimeters is equal to 1 meter and 10 decimeters is equal to 1 meter. So we can say that 100 centimeters is equal to 10 decimeters. Now we want 1 decimeter, so we'll divide it by 10. So if we divide this by 10, so we have 10 centimeter is equal to 1 decimeter. So 1 decimeter specifies you 10 centimeters. So the first 1 centimeter, 1 decimeter can be divided into 10 parts and each part represents you 1 centimeter each. So this is 1 centimeter, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you will divide this 1 decimeter here into 10 parts and it is denoted by your centimeters. Now we'll represent the units. So now this is your secondary unit or sub-unit which is centimeter. Here your primary unit would be your decimeters, and this is your RF on the right hand side which is your 1 by 5. So decimeters, centimeters, in which the decimeter is your high unit and your centimeter is your lower unit. So decimeter would be your primary unit and centimeter would be your secondary unit. After drawing this scale, we'll just show the length of 7.4 decimeter on it. So starting from this 0, we'll show this 7 below before your fraction. This 0.7 would be specified in the primary scale, and after your dot point we'll be specifying this 4 from your secondary scale. So let us start to define this 7. So 0, 1, 2, 3, 4, 5, 6, 7. So we have drawn one line from this 7. So this is 7, specifying 7 decimeters. 0.4 decimeters will be using secondary scale 0, 1, 2, 3, and 4. From 4, draw one line. So this will specify you 7.4 decimeter. So once again, why I have divided this into 10 parts? So we know that this is your 1 decimeter. So if we divide further into 10 parts, we will be having the centimeter. Why centimeter only? So we have to use this conversion table. 10 decimeter is equal to 100 centimeter. That means 1 decimeter would be is equal to 10 centimeters. So this we will call it as centimeter. So this is very easy. It was only one trick that we have to convert this maximum length 1 meter into 10 decimeter. Why we are converting this into decimeter? Because we want to show only decimeters and centimeters here. So that's why we'll convert this into decimeters. And then after we have to draw this example. Very easy. So example is over. So let's move forward. So we have to remember to construct the scale, the data required is first the RF of the scale, second the unit which it has to represent like millimeters, centimeters, meters or kilometers in MKs or inches, feet, yards or miles in FPS, third the maximum length which it should measure. If the maximum length is not given, some suitable scale can be assumed, suitable length can be assumed. Number 4, actual length of the scale to be constructed on the drawing sheet, which can be calculated by actual length is equal to RF into maximum length to be measured by the scale. So this is all from my side. Do not forget to share it with your friends and like and subscribe to show your love and support. Keep learning, stay connected. And if you have any doubts or queries, feel free to comment below. Bye-bye.